Okay, hi guys. Today I'll be covering chapter 5, which focuses on your graphs and graphical solution. Let's look at the learning objective. Firstly, uh, you should be able to draw graphs for a function which goes y equals to ax to the power of n, where n is between -2 to 3. So earlier we have covered uh two graphs, which is your quadratic graphs, y equals to ax square, and your linear graph, which is y equals to, for example, y equals to ax. Okay? So, in a way, you should be familiar with uh, the equation when your n is equals to 1 or 2. And then similarly, when your n is equals to 0, it will be y equals to ax to the power of 0, right? So this basically equals to a. Y equals to a. Okay? So essentially this is a straight line. It should look something like this. Y equals to a. And this intersection is a. Okay? So in a way, you should know between 0 to 2. So the only new components we're learning is -1, -2, and 3. So these are the three graphs that we'll be covering today. And then another type of graph that you need to know is how to draw a graph which goes y equals to ka to the power of x. So in this case, it's x to the power of something, but over here it is a to the power of x. So x in this case is your power. Okay, then the third point is estimate the gradient of the curve, which is fairly simple. And lastly, it is application-based question. Okay, since today's lesson is going to be on an iPad, right? I won't be able to draw the graphs, but we'll go through more the graph drawing techniques during our actual lesson. So for now, it'll just be like the theory for this chapter. Okay, so let's get started. So, uh, So these are for the learning objective one, these are the different types of graphs. So for y equals to ax cubed, it looks something like this. So if a is positive, it looks like this. So it goes like this. And if it is negative, it goes like this. Okay. Just roughly know the shape, uh, so that you're familiar with how to sketch when you're given the equation. Okay. So this is just for a cubic function where it's just ax cubed, so it will intersect the origin because there's no y-intercept. However, if you have a cubic function which goes ax cubed plus bx squared plus cx plus c, sorry, this is not a power, cx plus d, then your equation may not pass through your origin. So whether it passes through your origin or not depends on your d value. Okay. So if d equals to 0, it passes through origin. So in this case, d is your y-intercept, okay? So if d doesn't pass through, if d is not equals to 0, then it wouldn't pass through your y origin. Okay, so let's see. So these are the two graphs. So when your y is, so when your a is greater than 0, it's quite similar to your earlier one, just that now it has x-intercepts as well. Okay? Yeah, so earlier, if you see over here, you didn't have any x-intercept. Your only x-intercept is at your y equals to 0, which is your origin. Okay? But in this case, you have x-intercepts. And how do you determine the x-intercept? You equate your y to be equals to 0. So if you see over here, right, if you equate your y to be equals to 0, okay, let me write. If y equals to 0, then you will get ax cubed equals to 0. Then if you solve this, you'll get x is equals to 0, which is why the only x-intercept is your origin. But in this case, if you equate your y equals to 0, since this passes through your origin, your d is equals to 0. So when y equals to 0, you get ax cubed plus bx squared plus cx is equals to 0. So this is a equation where you can solve. It's similar to your quadratic equation. Okay, so you can just plug it in your calculator and solve the question, which is why you have x-intercepts. But the shape is generally the same. Okay, now your squared function, so you should be familiar with this already. So y equals to ax squared. If your a is greater than 0, it is a smiley face curve with a minimum point at the origin. And then if you have y equals to ax squared plus bx plus c, so in this case your a is less than 0, okay? So it is a frowning face curve with a maximum point, and your y-intercept is at 0 comma c, which, yeah. So for this kind of curve, you need to know how to find. So how are you going to find the two x-intercepts? So how you're going to do that is by equating your y to be equals to 0. And how are you going to find the minimum or maximum point? Alright, so this is just a quick recap from your previous lecture. Okay, so now let's go on to the fourth type of graph, which is your reciprocal graph. So if a graph that goes y equals to a over x, so again, just simply know how the shape of this graph goes. So just a point to note that your this point would never intersect your y-axis. So this is called a asymptote. Okay. Similarly, this point here would never intersect your x-axis. Same for these 2 points. Okay. Over here and over here. They will just go along the y-axis, closer and closer to the y-axis, but never touching it. Okay, then if when you have a graph y equals to a over x squared is similar to this, just that there is no negative portion when your a is greater than 0, and when it is less than 0, they are all negative. Okay? Okay, now your second learning objective for today, which is your uh graph a to the power of x when x is in the power. So it is a graph that goes like this, just a simple curve. Again, this point is a asymptote. So your uh, graph will never touch the x-axis. Okay? Okay, so just some things you need to know for this graph is that you need to know how to find the y-intercept. So how you find the y-intercept is by equating your x is equals to 0, and then anything to the power of 0, you will get 1. Okay? Okay, so let's take a look at this. So if you have y equals to kx, then your intercepts becomes k. Because a to the power 0 gives you 1, and when you multiply it by k, you will get k. And then similarly, if you have this graph, but if your a is negative, then you would get a flipped version of it that looks like this. Okay. All right. So yeah. Okay. So can you pause the video here and then see which graphs, so among A to H, correspond to which number? Okay. So I'll go through the answer during your lesson. Okay. Yeah. So do look back into the video if you're not sure how the shape of the graph goes. And then, yeah. So just a quick look, you should know that uh, this is the reciprocal one. Sorry, not the power graph. Power. And then this one is a over x square. Similarly, a over x square. Then these two are a to the power x, and these two are x cubed. Okay? So given this, you should be able to find out which one is which. Uh, yeah, so I'll go through during lesson. So do let me know if you have any questions at this point. Okay, so now is the third learning objective for today. Um, so given let's say if you have drawn a graph, right, and then the question asks you to find a gradient at, let's say, your x equals to minus 2. So for example, let this be x equals to minus 2. X equals to minus 2. So how you're gonna find the gradient is you're gonna draw a tangent. You're gonna draw a tangent. Okay, it's quite hard for me to draw an iPad, but you're gonna draw a tangent at the point where the x is equals to minus 2, and then you're gonna get 2 points. 2 points. Okay, so one thing to note when you draw tangent is that make sure this angle and this angle are somewhat the same. So it's not too tilted or yeah. So for example, you can also draw a tangent which looks like this. So in this case, if it's it looks more tilted than the previous graph. So just take note of it, okay? Make sure your tangent line is even. You see? You can draw a tangent like this, or yeah. So just make sure that the line is even. Okay, it's a bit hard for me to make it even here, but we'll go through more in practice. But essentially, once you have drawn a tangent line, you take 2 points. Make sure they are quite far apart, so you don't take 2 points from like here and here, because if it's too near, then your gradient would be inaccurate. Then you get the coordinates. If you want, you can make it even longer as well. So it doesn't have to be at this point. It can even be. Okay. So let's say if you have drawn, it can be over here and over here. And then you find the coordinates. So let's say over here is x1 comma y1. And then you have x2 comma y2. And then you calculate the gradient of this point. So that's how you find the gradient of a curve. So your gradient would be y2 minus y1 over x2 minus x1. So once you get this, you'll get your final answer. Okay. Okay, so the last part is, if I'm not wrong, application-based question. So just an example would be this type of question. So uh you have been told that station A and station B are 8 km apart, and they give you the time and distance, okay? So initially they've given you the scale, and they have asked you to draw the graph and then use the graph to estimate the time taken to travel the first 4 km of the journey. Okay, wait. So let's see. Okay, sorry. I want you to try out this question by yourself. I will go through the next question with you. Okay? Okay, so this is another. Okay, so in this case, this is a distance time curve. So just note that gradient of distance time gives your speed. Okay? And then gradient of speed time gives acceleration. Okay, now given all this information, let's take a look at question 2. Okay? So question 2 is a speed time graph. So you are given the equation of the velocity, which is 3t square minus 15t plus 20. And then they have given you these values. So the first step is to find your values a and b. So that should be fairly simple. Uh, you know your t here, you're given the equation, so just substitute. So your v is equals to 3 times 1.5 square minus. So just plug it into your calculator, you get the answer for A. Then again, just plug it, you will get your answer for B. So this is your part A. So your part A should be a giveaway. So do not lose your marks in part A. It's quite simple. And then your next part is drawing the graph. So again, uh, so you should know that this is a t square. So it's a quadratic graph. So the shape should roughly be like this or like this. Okay. So this is where it's helpful to know the shape because it makes it easier for you to plot the points. So again, just plot it and then uh, use your curve ruler to draw a graph. I'll go through more techniques on how to make the graph look nicer during our actual lesson. Okay, so once you're done, you should have a graph that looks like this, okay? And then your part C says, using your graph, estimate the value of t when your speed is 10 meters per second. So again, your speed is your y-axis. So just draw a dotted line to your graph. And then at the point it intersects, okay, at the point it intersects, which is here, draw a dotted line to the x-axis and read off this value. Okay? So in this case, at 10 meter per second, note that there's not one value, but there are two values. So if you extend this, it cuts the graph at this point as well. So again, extend to your x-axis, and then, so you will get 4.2 or 0.8. Okay, so that's your part CI, the time at which the acceleration is 0. So again, remember what I said, your acceleration is your gradient. Okay, so they're asking for the time when your gradient is equal to 0. Just a quick recap, your gradient is 0 when your line is horizontal. Okay, so once you know this, you should find the point where, which you find the turning point. Because at the turning point, your tangent is basically a horizontal line. So again, find the turning point and you bring it down to your x-axis and your answer should be at 2.5. Okay, so this answer 2.5. Okay, and then the third part is asking for the gradient at t equals to 4 and explain what this value represents. So remember earlier, so even if you get your gradient wrong, you should get this part correct. So earlier we have mentioned that this is your acceleration. Okay. So like what I've mentioned earlier, you go to your point where your t is equals to 4 and then draw a tangent. Okay. So once you draw a tangent, you choose 2 points. So make sure you choose two nice and readable points. So they have chosen this point and this point. Then, yeah. This dotted line is just a way to know the to let the marker know which dotted line, which point you have chosen. Okay. So if I drew the dotted line from here, that means it tells the marker that I've chosen this point. Okay. So you won't get penalized if you don't write it, but I suggest you write it because it's clearer for your working. Okay, so once you have drawn this dotted line, again, just plug in the gradient equation and you'll get it's equals to 9. Okay, now let's look at the last part. The time interval when the speed is less than 15 meters per second. So 15 meters per second. So again, it's this straight line here. Okay, I can from here. Okay, so there are two periods where it is less than 15 meters per second. So again, draw a vertical dotted line to indicate your x intersection and x-axis. Then once you have it, so this is the time interval. Okay. So you just read off the points. So in this case, is when your v is less than 15 seconds. Sorry. When your t is between 4.65 and 0.35. So you see, this point is 0.35 and this point is 4.65. Okay, so this is a typical application-based graph question. So you should be able to do this. Normally it's about 10 to 15 marks. So honestly, if you ask me, right, your graph questions are a giveaway for you. So it's one of the best ways to score like a solid 10 to 15 marks because it's quite straightforward. Normally, the question structure is very similar to the one that you have seen. Your first part, they will ask you to find the unknowns. Second part, they will ask you to draw the graph. And the third part is using the graph to estimate certain points and values or to find the gradient. So it may not always be speed or distance, so it may be other contexts as well. And you should be able to use the context to find out what the gradient means. Okay? So that's it for today. So that marks the end of today's lesson. So based on what you have learned so far, please do try out your question one. I will go through uh I'll check your working during our lesson time and we'll do more practice on this as well. If you have any questions, do let me know. And I won't be doing a summary for today because it's just the content on the different graphs. So yeah, that's it for today. Thank you for watching.